Hello, everyone. I'm going to talk today about how and maybe why a little bit to integrate small-scale fisheries into marine spatial planning. I thought I should start by giving you an overview of the importance of small-scale fisheries worldwide. They employ approximately 52 million people, and more than a third of these people are women, here depicted in green. They account for about a third of all the fish caught in the sea, and most of this goes to direct domestic human consumption. Therefore, they provide vital nutrition to billions of people, and they also provide a safety net for some of the poorest people in the world. Small-scale fisheries are usually informal and unregulated activities, and they're poorly documented. They are politically marginalized and generally squeezed by other activities in space. There's still a lot of work to be done to properly represent small-scale fisheries in MSP. Some of the key questions that we have to incorporate small-scale fisheries into MSP are, for example, where are they fishing? Which areas are more valuable? And I put an asterisk there on valuable because I don't only mean like catches or economic value, but social value, cultural value, and other things that have been discussed during this workshop. What's the effects of other users or uses on fishers? What are the medium to long-term expected changes in fisher distribution, for example, due to climate change? What are the impacts on the ecosystems of small-scale fisheries? There are several methods to obtain some of this information on spatiotemporal activities in small-scale fisheries, such as interviews, participatory mapping, area surveys, and in situ gear counts. But these mainly provide a snapshot of the activities conducted by small-scale fisheries. Low-cost technologies now, such as tracking systems, are increasingly being used to monitor the use of space of fishers in time. And you can see one of these small trackers on the right bottom that's mainly used in the transport industry, and the associated track is on the left-hand side of one fishing track. Mobile phone apps are also increasingly being used to track fishers, and there's several machine learning techniques that we're using now to classify fishing from non-fishing activities. In the example on the right, you can see trolling in yellow and steaming in purple, for example. I thought I should show you a couple of outputs that come from these tracking systems. This figure shows the relative fishing intensity of the artisanal Hake-Gilner fishery in northern Peru. And fishers, in this case, were interested in demonstrating to government that most of their activities are now conducted outside the area designated exclusively for artisanal fisheries. That's the yellow line, so inside the yellow line to the coast. So they are now competing with industrial fisheries for use of space. The figure on the right shows the number of vessels associated to a particular grid cell size of 1 by 1 kilometers. So the darker the blue, the greater the number of fishers. This shows, the greater the number of fishing vessels, really. But this shows how localized small-scale fishery activities can be. And this is just an example where social aspects such as the number of fishing vessels or the number of fishers that are dependent on a particular area could be prioritized over catch or fishing effort. But of course, this will depend on which societal policies are agreed during the marine spatial planning process. Just to give you an overview of the current initiatives, tracking small-scale fishing vessels in the North Sea and the North Atlantic, there are more than 2,000 vessels now with some sort of tracking device. England and Scotland are committed to equip the whole small-scale fishing fleet within the next couple of years. Some regions in Spain already track all vessels, and there's a lot of tracking vessels that are perceived to pose a greater risk to the environment. So experiences are not just in Europe. In East Timor, the World Fish Center has implemented a project now tracking approximately 430 vessels. But most importantly, there are several initiatives that are integrating the data from these trackers with user-friendly interfaces for managers, other stakeholders, and importantly, fishers themselves. So visualization of the fishing activities can help engage fishers into this marine spatial planning process, and perhaps engage fishers that would previously not have been able to, for example, spare a day or a few days to participate in stakeholder meetings, but they could still provide some of the information on fishing activities. Also, using these visualization tools and how their activities overlap, in this example, you can see a marine protected area in the green line. You can maintain perhaps fishers engaged in the process. So the main key take-home messages and how they integrate into the processes of marine spatial planning are: small-scale fishers are really important and dynamic, and they need to be properly represented in MSP. The technologies are ripe and ready to collect spatiotemporal data. This could create a platform to improve fisher engagement, facilitate discussions between fishers, other stakeholders, and planners, and it's an alternative way to give information back to fishers and perhaps incorporate them for longer into the marine spatial planning process. Thank you very much for the opportunity.